This program is brought to you by the Ministry of Education and Vocational Training Zanzibar in collaboration with Good Neighbors. The program is funded by KOICA.
Dear listener, you may learn many useful concepts of physics in this program as far as you pay attention. However, our program today is special for Form 1 physics learners. The program will provide free discussion on Number 1. The concept of derived quantities. The concept of derived quantities. And number 2. Examples of derived quantities. Examples of derived quantities. Self-assessment is allowed while the program is going on. For our lovely teacher, this program will help you to prepare a simple lesson for your students so that they will learn with joy and improve their performance.
Good evening.
Good evening.
How much is this juice per bottle?
It is 3,000 for large bottle and 2,000 for middle bottle.
But the bottles look the same. Why the price is different?
No, they are different. The green bottle is 1 liter and the yellow bottle is 1.5 liter.
Oh, okay, thank you. I will come later.
Okay, no problem.
He really confused me. The same bottle has different volume. How come?
Hey, Salma. Why are you like that? Are you sick?
I'm fine, thank you. But the juice seller confused me a lot.
What happened?
He has the bottle of the same size, but he told me they have different volume.
It seems like possible because volume is derived quantity. It depends on the height and radius of bottle.
What? Derived quantity?
Yeah.
What is that?
You are surprised as if you were not Form 1 student before.
Yeah, I was, but I don't remember anything about that.
Sorry for that.
Thank you. So can you tell me more about derived quantity?
Yes. Derived quantity is the quantities which are expressed in terms of fundamental quantities. Derived quantity is the quantities which are expressed in terms of fundamental quantities.
Okay. Let us go to juice seller. Maybe you can help me.
Yes, let's go.
Yeah, here is the place. Hello,
Hello.
I'm back. Can you show me those size of bottle, please? I need to choose one.
Here they are. This is 1 liter and this is 1.5 liters.
Have you seen? These are the same.
No, they are not. They have same height but different width. The 1.5 bottle is wider than 1 liter bottle.
Uh-huh.
Yes, and this leads to have different volume.
Okay, you win.
Okay, thanks. But are you still confused?
No, I'm okay. I still force my mind to think about derived quantity.
But there are a lot of examples about derived quantity.
What are they? Tell me, please.
Listen carefully, please, okay?
Okay.
When you take that bottle of 1.5 liters filled with the juice, and if you put it into balance, you get the mass of bottle. Then do you know what will you get?
Yes, I remember it. That is the density because of mass divided by volume.
Yeah, sure. That is example of derived quantity.
Oh, I think I want to go to somewhere called Tungu.
Tungu?
Yeah.
What are you going to do there?
I was ordered to go to take some fruits from my aunt.
Well, I will give you a company, okay?
Really?
Yeah.
Okay. We are close to the driver. I always hate sitting close to driver.
Are you afraid of facing accident?
No, I hate to see the driver while forcing to pass at the narrow areas.
Don't worry, this driver drives fairly.
What speed is the driver now reaching?
Let me check first. Yeah, it is 60 kilometers per hour.
Oh my god, it is high speed in this area.
I think it is average. But Salma,
Yes?
do you know that the speed is also derived quantity?
Oh, how is that possible?
That is because speed is the ratio between distance divided by time.
Oh, it's like that.
Yeah.
Okay. Do you remember another one?
Have you seen that writing at the top of the driver's seat?
Yes. It is written as maximum weight is 500 newtons.
Oh, that weight is also derived quantity. It is the product of mass and acceleration due to the gravity.
So do you mean that speed, volume, density and weight are examples of derived quantities?
Excellent, you are right. But also there are other examples.
Okay, we'll discuss it later. We are nearly there.
Alright. It is my first time to reach here. Where are we going?
Let us move this way.
Okay, let's go.
Let us hurry. It will take us a few minutes to reach where we go.
Okay, let's hurry.
What?
Madam, guess, is this really you?
Why are you surprised like that? It's me.
We didn't expect to see you here. Where are you coming from?
I have a farm here, and now I have started to build a new house and also to dig a well.
Wow, congratulations for that.
Thank you. It is not far from here. It's about only 3 minutes to walk.
Okay, let's go to see your new place.
This is my farm.
Wow, it is very big.
Yeah, its length is 170 meters and its width is 55 meters.
Oh,
That means this farm has the area of 9,350 square meters.
Yeah, sure.
is that also example of derived quantities?
Exactly, you are correct.
How come you mentioned the derived quantity in my farm?
We were talking about it on our way here.
All right, that is good. I have digged the well in my farm, and I have preserved the water in the tank of 2,000 liters. See over there?
Oh my god! That tank preserved the 2,000 liters of water.
You are right. The volume of the water is 2,000 liters.
Okay, I knew that volume is expressed only in meter cube.
No, there are other units like liters, millimeter cube, milliliters, and others.
Even in area, there are square meters, inch square, centimeter square, and others.
That's very interesting. I understand.
What is going on there?
Those are the people preparing an area for building a house.
Oh, can we visit a site?
Yes, why not?
Okay, let us go.
What is that box made by iron?
That is a tank, especially for measuring the volume of small stones.
How do they find the volume of that tank?
Do you have a ruler in your bag?
Yes, I have.
Take it and measure the length of your mobile phone.
It is 12 centimeters.
Okay, then measure the width of your phone.
It is 5 centimeters.
Then measure its height.
It is 1 centimeter.
When you multiply these 3 dimensions, you get the answer in cubic centimeter.
Uh-huh.
Yes, and that is how you find the volume of any square object.
Thank you, madam.
You are all welcome.
I think we are late. Let us go to your aunt, then we can go back home.
Okay. Bye-bye, madam.
See you next time. Bye.
Salma,
Yes.
can you mention to me the examples of derived quantities which you know?
Pressure,
Mm-hmm.
force,
Mm-hmm.
voltage,
Mm-hmm.
and velocity.
Very good. Do you still remember?
Yes, but I have a question to ask you.
Well, ask me, my friend.
How can you differentiate between fundamental quantity and derived quantity?
That is a good question. The fundamental quantities are independent of other quantities, while derived quantities depends other quantities to be formed.
Oh, very good.
Thank you.
Fundamental quantities are independent of other quantities, while derived quantities depends other quantities to be formed.
Okay, I'm very happy today. Thank you, Salma.
Wow, we have arrived. So we will discuss other things on our way back home.
Yeah, that's a good idea.
Okay.
Soma, soma mwana soma, uwe mjini. Soma, soma mwana soma, uwe kijijini. Soma, soma mwana soma, ukiwa na mahitaji maalum. Soma, soma mwana soma.
All right, we were together in your discussion, and I am so happy. Hopefully, our dear listener has gained a lot through your discussion. Now, here are the questions about the topic for further discussion. Number 1. How can you calculate the volume of water that is filled in a drop bottle? How can you calculate the volume of water that is filled in a drop bottle? Number 2. List down 5 examples of derived quantities and their units. List down 5 examples of derived quantities and their units. Number 3. What is the difference between derived and fundamental quantities? What is the difference between derived and fundamental quantities? Here is the end of this program, but you are so welcomed in the next program. Until next time, bye-bye.